welcome you to the second in our webinar series around the Alpha SDK. My name's Rachel, I'm a tech evangelist here at Lisk, and I'm here with
Phil. I'm working at the backend for 6 months now. And Lead, I am a front-end developer who's working on Lisk app. I've been here for over 2 years now.
Cool. Today it's a really exciting webinar for you because we're going to be talking you through the first proof of concept we built using the SDK, and that is our Lisk Bills application. So just to go over the overview for today, I'm going to give you kind of a brief overview of the business use case for the application and what it will do. Then I'm going to give you a live tech demo, so you'll get to see what the UI looks like and a quick glimpse at the blockchain underneath it. Then we're going to go into a deep dive into the code for both the blockchain code and also the code in the browser, which is talking to the blockchain. At the end of this, we're going to do a short Q&A session. So whilst we're doing the webinar, if you have any questions around this proof of concept specifically, please pop them in the box and we'll address some of those at the end. Cool. So use case. First thing, what are we building here? To come up with the idea for the proof of concept, we did a kind of little mini hackathon. We had a couple of ideas which we pitched backwards and forwards. And in the end, we settled on this use case of creating invoices. Those of you who've ever worked with freelancers or have been a freelancer yourself will be very familiar with the process of creating an invoice, possibly chasing it for a while, and then receiving your money in payment. We thought this would be actually a really good use case for the blockchain, because not only could you receive payment using cryptocurrency, but you could also write the invoice itself to the blockchain, so it's there and everyone knows it's been created, and then everyone knows when it's been paid. So how did we get started? First of all, we did some brainstorming. We sat down and we got the whiteboard out, and we worked out what would be the kind of specifications that we needed to meet. Looked at the user flow, what were we trying to achieve with our application. Once we had that, we were able to kind of look into each transaction type that we're going to create in a little bit more detail and figure out how we were going to construct those. Once we knew that, then it was time to do some coding. And we built this application very quickly, just in a matter of days. As it is, it's meant to be a proof of concept. It's not production-ready code, but it's a really useful thing to see how it's quite quick and simple to kind of build something quickly, and also have a look at the code and see how that works, and hopefully inspire you guys there who are sitting at home to come up with your own proof of concepts, your own ideas to build with the Lisk SDK. So, what tech stack did we use? Over here on the left, you can see the tech stack for the blockchain. Those of you who've been following this for a while will know we're all about JavaScript. So of course, we're using Node.js and also Postgres for the database there. This example, we're just going to be showing you a local blockchain. So it's just one node running locally on a computer. And that's the easiest way to start your development process and allow you to kind of rapidly develop. And that's running on port 4000 if you're particularly interested in that. We also have a front end, and this was a front end that was built using Create React app. We're using React a lot in our front end tech stack here at Lisk, and it's also a very ubiquitous front end framework in the web in 2019. So it's probably something you'll be familiar with on some level if you are a front end developer. And that's running on port 3000. We're also holding the keys in our front end, and it's using HTTP to communicate to the local blockchain running on port 4000. So it's kind of high level overview of the tech stack there. And with that, let's dive straight into the demo. So like everything we do here at Lisk, this is all open source. It's there for you to have a look at. In fact, the main reason why we built this proof of concept was for a learning tool for the community. So it's not something that we're going to be launching as an actual application, but it's here for you to kind of have a look at, have a dig around in the code and figure out how you could tweak this for your own uses and how you could come up with your own custom transactions for your own use case. So please visit Lisk SDK /examples. You can see we've got the example code for both the Hello World and the Cashback tutorials here. And you'll also see there's this folder called Invoice. That was the name we used before we came up with Lisk Bills. And if you dive into Invoice, you'll see we've got 2 folders here, one for the client, which is holding all of the front end code, and one for transactions, which is containing all of the blockchain and the transaction code. So this is where you can go and check it out yourself. I'm just going to dive over into my terminal now, and I'm in the transactions folder. And I'm just going to use, as we do normally, using Node to run the index file, and then using Bunyan to print out the logs. This will be very familiar for those of you who've ever worked with our SDK already. You can see it's setting a lot of stuff up. We're creating the delegate forging accounts, the key pairs here, and at the bottom we can see that the blocks are starting to populate through. So now that we have that, we can jump over into another tab in the terminal, and then we're just going to make sure that we're in the client directory, and then we'll use npm start to launch our create React app interface. And I'm just gonna, here we go, it's just launching actually. So here we go, we can see this is our login screen, and I'm just gonna grab a passphrase from one of the delegate accounts that were set up when our blockchain launched, and put it in here. And we can see that I've logged into the interface, and I can see my address up here. I can also see the balance. So this is, quite a large balance. It's almost 100 million Lisk. And we can see here in the invoices, the kind of history of invoices that have been created and the invoices that have been paid there as well. But I'm also going to open up another incognito browser so we can log in as a different user, just to demo you the creating an invoice for somebody else. So here I'm just going to grab, again, another passphrase, but this time for a different address, and log straight in there. And we can see this account, it's got a different address, and it's got a balance of around 1,500 tokens. As I say, it says Lisk here, but in this case, because this is a local blockchain, this isn't the Lisk token that we're used to transacting on Lisk main chain. This is a native token for this blockchain. It's not what the list that you'd find on exchanges or the list that you may already hold in your hub. There we go. So let's, now we can have, and again, we can look back at the history of invoices that have been created. So let's create another invoice, and we'll invoice this slightly richer account. So I'll just grab their address. And here, creating the invoice, we can put in the address that we want to send it to, and let's put in the amount, let's say 2,000, and we're going to add a little note for creating a webinar. Now that I've done that, this is all the information that we need to create our create invoice transaction. And when I hit this, it's going to send that invoice, create invoice transaction. If we go back to our invoices, we can see that's already come up here, and it's actually in the to be paid status, as it says here, pay. There we go. Of course, I don't want to pay my own invoice here, so I'm going to jump back over to the account that I created it for, and I can just click on here and say, yep, looks good. I'm going to pay this invoice. And if I go back into invoices, within 10 seconds, which is the default block time that Lisk ships with, that pay should turn into paid. There we go. So we can see actually that's been settled, and that's all been settled on chain for both the invoice creator and the invoice payer there as well. So yeah, that's just a kind of quick dive into the UI. Now I'm going to hand over to Mikael, who's going to take us through a deep dive on the code that was used to create the transactions.
Right. So let's dive into the transactions. So as you know now, we have two transactions, the invoice transaction and the payment transaction. Let's dive into the first one, the invoice. So as you can see, we are extending from the base transaction here. That's an abstract class that holds all methods we need to implement for the custom transaction. The first one is the type. It's a static getter, and it returns a unique number for your transaction. The next one is the fee. The fee is used for determining or setting the fee the user has to pay for sending this specific type of transaction. For now, we have set it to 10 to the 8, which is equal to 1 Lisk. Why this 10 to the 8? Because we are counting internally in bedos, and 100 million bedos is equal to 1 Lisk. So that's why we set 10 to the 8. The next function for our invoice transaction is the prepare. The prepare method is actually responsible of caching data we will later use in the apply asset and undo asset methods. So normally we would cache here the sender account, so we can later modify it inside of the apply asset. But because we always have to call the super method, the base transaction will by default cache the sender account. So next we come into the validate asset. The validate asset will perform only static checks for the type of the data. So here you can see we're checking if the client is a string, or for example, description is also a string. In case an error occurs, we push the error into the errors array with our custom transaction array. This object is coming from the Lisk transactions. And in case the array contains errors, the transaction will be discarded. One quick note on this: we cannot access the state store, which the data which we prepare in the prepared step, inside of the validate asset. So more advanced validation needs to happen inside of the apply asset. And we will see this in the payment transaction. So to move on to the apply asset, we will try to get the account for the sender ID, which was cached via the super call. Next, we will first modify some data in the asset field. We will try to increase the invoice count for the user. As the user might have not an invoice count yet, we set it to 1, or we increase the count. And next, it's also important to store the ID of the transaction in the array of invoices sent, so we can later use it. And at last, the most important step, we have to store back the modified sender account into our store. So that's happening here with the set method. And at last, we enter the undo asset method. It's actually a quite important method because you need to tell the application as well how to roll back the changes you just made. So for example, if we want to decrease the invoice count, so we decrease it by 1 or set it back to undefined, and we remove the ID from the invoices sent array. Why do we need this? In case, for example, a fork occurs and we have to roll back from chain with type A to another common block, the blockchain will use this undo asset function to undo all of these transactions. Okay, so now we have covered the invoice transaction. We can move on to the payment transaction. This one will actually extend from the transfer transaction because the payment transaction will be transferring tokens, so we extend it from transfer transaction. And again, we will define the type for this payment transaction. As it has to be unique, we increase it by 1 and set it to 14. You will notice that we did not implement the fee method here. The reason for that is because it's implemented in the transfer transaction class, and we actually want to use the standard that we have set. So if you go look into the transfer transaction class, which also extends from base transaction, it uses the fee, transfer fee. And if we go look into that, the transfer fee is coming from the constants. You will see the transfer fee is set to 10 to the 8 multiplied by 0.1, so it's equal to 0.1 Lisk. To get back. So next we have the prepare method. We first call our parent method again to cache the sender account. This is important for example, if I can go back, so the transfer transaction. In the apply asset, you will see we will use this account again to, for example, deduct the amount from the balance. Let's go back. And then we will also cache the invoice transaction. So we are sending the ID of the invoice transaction in the asset.data. and we will use this to cache the transaction. This transaction will be used inside of the apply asset. We will first see if the invoice actually exists. If the invoice transaction exists, we will check if the amount that we have transferred with the transaction is at least equal or larger than the amount requested in the invoice. If not, we will push an error and this will invalidate the transaction. As you can see, we also didn't make use of a validate asset. That's because of the reason we just said. We have to access the state store to get this invoice transaction and do the verification. And as we don't have access to the state store in the validate function, we move this validation logic into apply asset. At last, we again have the undo asset function. We are not rolling back any changes here. We're just calling the parent method again, as the parent method has to roll back the tokens that have been sent and give back the fee to the user. But we didn't change any data in the state store in the apply asset function, so no further action is needed except for returning the errors. So that covers the payment transaction, and that's it from the deep dive from my side. So now I will give the word to Vit, and he will explain further about the front end.
All right. So thank you, Michiel. And now taking over to the front end, I want to connect the two things that you've seen so far, the UI and the code of the transactions. And so for that, like I don't want to go through everything in the front end. Like there is the boilerplate for like the pages, and I just want to show you the sign-in page code and then the code of sending the invoice transaction. And so if I go to the Lisk SDK examples repository and search for sign-in in here, yeah, there is component sign-in page, and on this one it's a basic React component, and this whole example is built with React just because we are using React here, but like it's just an example. You can use any other front-end framework or library you want to. And here we have the actual sign-in page, and I'm showing this one just to show you what happens when you click on the sign-in. So like the sign-in button has on-click, which calls this on sign-in click, and basically we are using just some React hook in here to use the passphrase to sign in, so that the passphrase is stored in state of the application and can be later used when the user gets to sending invoice or paying invoice. And let's get to the sending invoice. So let me just sign in to an account in here, and then here on the send invoice page, basically we want to have a look into the code, what happens when the user clicks the send, and that should show how this is connected to the backend of creating invoice transaction. So going back to the examples repository, let's search for send invoice, and we can find send invoice page, where at some point we have a form with the send invoice that corresponds to the form we have in here with the client address, amount, and description. And this one has on send click. Maybe here just a little bit of technical detail. Here there is one extra component for transaction form, and that's just because this send invoice is very similar to the pay invoice, so there is just something to keep the code a bit dry, but you can have look yourself into the repository and see what's in there. And so now the question is, what happens on send click? And here we have the on send click function. It looks long, but like most of it is just setting the state of pending at first, then calling some function and then setting the state to success or error based on how the transaction was resolved. And the interesting part here that we want to look closer at is this send invoice that is being imported from some API utils where we're gonna have a look next. And here just you can check that we are passing in there the client requested amount and description that correspond to the fields on the page, and also the passphrase that we got from the previous login page. So now when we go to the implementation of this API util, we can get finally to connecting the front end to the transaction definitions, and that's specifically in this create invoice function where we create a new invoice transaction, and the new invoice transaction actually comes from here. It's called Lisk Bills transactions, but if you check the package JSON yourself, you'll see that it's just coming in from the other folder in our project. And this is the beauty of using JavaScript here, so that on front end and back end we are using the same invoice transaction class, and here we just feed the data into it. So like we are getting the client, request amount and description again, which we put into the asset field, which is the custom part of a custom transaction. Here you can again see what Michael was mentioning before, some conversion of amount, which is that shifting by 8 decimal points from LSK to BEDOS, so that user enters one Lisk, but then we multiply by 10 to power of 8 to get the basic unit, the smallest unit of the token. And this convert Lisk to BEDOS comes from our SDK, from our Lisk transactions module. There is a few more similar things from the SDK used in here. Another one is to get the sender public key from our passphrase, which uses this get address and public key from passphrase, which comes from our package Lisk cryptography from the SDK. And then we just specify recipient ID and timestamp, which again is converted by logic from our SDK to the Lisk epoch, which uses the starting point of the Lisk blockchain main chain. And so that was the create invoice. And once the invoice is created, we just need to sign it with the passphrase, so that we are not sending the passphrase over the network, just the signed transaction with the signature. And then we just broadcast the invoice transaction as a JSON, and using this get API client, which is just a very small function in here that creates API client with the server URL from our config. And this API client is again something coming from the SDK, specifically from the Lisk client package. And that's basically the core of sending your own custom transaction on the front end. You can have a look in the code on how the paid transaction is handled, and it's very similar, so I'm not gonna go through that one. And everything from this example is on GitHub, so you can have a look yourself, try it out. You can try to do whatever you want with it, and that's basically it from me.
Cool. Now we had a little bit of time. I'll just switch over. Hi, so thank you, Vit and Michal, for talking us through the code. It's really interesting to see the kind of core components of both writing the blockchain and communicating to it. So yeah, that's super stuff. We've got a little bit of time at the end just to go through a couple of questions. I know there might not be a huge amount on this, but let's just see if we got somebody asked the question, can this application handle tax? Of course it can't. Please don't use this as a real invoice application. It's just a demo application. So it would be really nice if we had something that could also send an invoice and work out the tax. Maybe that's something for the community to build on. But yeah, just to reiterate, this is just a demo application. And then what's this? And we had a user asking about the difference between smart contracts and custom transactions that we have on Lisk. I'd say it's quite a big topic, and it is definitely a different approach to writing logic onto a blockchain. But we found actually using custom transactions, you can actually implement a lot of business logic, like the business logic that we've shown you just now with the extra fields for creating an invoice. And it doesn't have the same overheads of creating a sort of a language like Solidity on top. So it's kind of a different paradigm. The other part of that question was around whether you have to run your own nodes to partake in a sidechain. And the answer to that is yes, you do. We have the Lisk main chain. That's been operational since 2016. So if you hold any Lisk, or if you sent any Lisk, or if you voted for a delegate or registered for a delegate, that's where that's happened. And that is live, and you don't need to run any nodes. The delegates and other node operators are handling that. But if you want to launch your own sidechain, then you would need to handle the node management yourself. But today we've just for development purposes, we've just had a single node running on a laptop because that's really easy to get started with. If you were to launch your own application, you'd obviously want to extend that out and deploy a number of different nodes there. Don't know if either of you would like to add anything to that.
It's perfect.
Cool. And I guess another thing that might be useful to just quickly talk about is like other ideas that we looked at when we kind of did ideation and figured out what a proof of concept to go for. I don't know if either of you want to talk about that. We also looked at doing a kind of an employee reward system, which is something that gained a bit of traction, but we thought actually invoices is something that we're probably all familiar with, and it will be easier for us to go out with. But we're really excited to see what other ideas the community come up with, and we know there's a group who are already building a Lisk bike, which is super exciting to follow. And we've got tic-tac-toe being made also by community members as well. So we're really hoping to kind of follow those projects and see a lot more of exciting use cases come out of our SDK as it grows and matures.
Right.
Have we got any more questions? Will we update this example using entities and add API requests to fetch unpaid bills, for example?
You can do this yourself. So it's basically using the existing API and passing a filter for this transaction type.
Cool. So I guess if we don't have any more questions, we can wrap up for today. But if you do watch this, or if you're watching this slightly after the webinar's gone live, we will be on Discord, and those of you in the community will know our Discord channel. We'll be on there tomorrow morning, all of us here, so feel free to kind of ping some questions and we'll pick that up as well. Yeah. Great. Thank you for watching, and also thank you, Vit and Michal, for jumping in on the webinar with us and sharing the code as well. Cool.